Hello everyone, my name is Bipin Abram, and in today's video we are going to talk about electric dipole. So let's get started. So as the name suggests, electric means we're talking about electrons, right? Okay, so electric means electrons. Dipole, di means we're talking about something which is not one but two, right? Di means two, right? Pole means we're talking about corners, right? That means we're talking about two corners here, right? So electric means we're talking about electrons. Dipole means we're talking about two corners, right? So now let's try to understand what electric dipole actually mean, right? So it is an assembly of two equal and opposite charges which are separated by some distance, right? Okay, now what does this definition tell us? This definition tell us that we have, it is an assembly of two equal and opposite charges, right? That means we need to have two charges first, right? And they need to have equal magnitude but of opposite nature, right? So let's say I have a plus q charge here, right? Then the next charge will be minus q, right? Okay, which are separated by some distance. Okay, let me keep a distance between these two, right? This is minus q and they are separated by some distance. Let me call this distance to be some d, right? Okay, this distance is some d. We have two equal and opposite charges. They are been separated by some distance. Then this system is what you call as your electric dipole. I hope that is understand. We are talking about electrons and they are separated by some distance at two different corners but equal and opposite charge, right? So what is your electric dipole? It is an assembly of two equal and opposite charge when they are separated by some distance, right? Okay, great. So I can even call this as dipole, because let's say I have 2q charge. So if I have plus 2q charge and next will be minus 2q charge and they are separated by some distance, let me say a, yes, this is also known as your dipole, because yeah, you have two equal but opposite nature of charges and they are separated by some distance, right? So this kind of system is what you call as your electric dipole, right? I hope that is understandable. Now there is a new phenomena which is known as electric dipole moment. Electric dipole moment, it is represented by p vector. Yes, you have heard it right, it is a vector quantity, right? Now let's try to understand what is this electric dipole moment. We understand what is electric dipole. We have to yet have to understand what is electric dipole moment, right? Okay, great. So it is defined as the product of magnitude of one of the charge, great, and displacement vector from minus q to plus q, right? Again, it is defined as the product of magnitude of one of the charge and displacement vector from minus q to plus q. Okay, first of all let's make the dipole, right? Okay, great. I have minus q charge, right? I have plus q charge. They are separated by some distance. Let me call that distance to be d, right? Okay, great. So according to our definition is saying it is defined as the product of magnitude, right? So dipole moment, which is represented by p, right? So vector quantity, let me write vector quantity, is defined as magnitude of one of the charge, right? Magnitude of one of the charge, right? So here the magnitude of charge is actually q, right? So I can write it over here, q. We are not going to bother about the sign because we are only concerned about the magnitude here, right? So q, right? Then magnitude of one of the charge and displacement vector from minus q to plus q. Now displacement vector minus q to plus q, let me call displacement vector to be d, right? D is the shortest distance between minus q to plus q, right? So displacement vector is your d, right? D vector is my displacement vector. Now this is what you call as your electric dipole moment, right? This is how you define your electric dipole moment, right? That means whenever you are given, let me draw another one. Whenever you are given, let's say I have given minus 2q charge, I have given, okay, this is minus 2q charge, I have given plus 2q charge, right? They have been separated by, let's say, a distance of 2a, right? Then I can define my dielectric moment to be, P is my dielectric moment. It is defined as magnitude of one of the charge, right? That is 2q is the magnitude of one of the charge, right? Multiplied by that displacement vector, right? That is 2a. This is the dipole moment for this one, right? Okay, like I said, dipole moment is a vector quantity, right? So definitely it must be having a direction, right? So the direction part is already given in the definition, right? Displacement vector from minus q to plus q direction. The electric dipole moment will always have direction from minus q to plus q, right? In the same case here, minus 2q to plus 2q, right? So direction will always be minus 2q to plus 2q, or in this case minus q to plus q, right? The direction is always from negative charge to positive charge. This is how we define our electric dipole moment, right? Sometimes we call it dipole moment. We rarely use this electric, name, but we just understand that we are talking about electric because we are talking about electrons, right? Charges are involved, that's why we term it electric dipole moment. Otherwise we just simply call it dipole moment. I hope that is understandable, right? Okay, great. So like I said, dipole moment is a vector quantity. Also, it's pretty simple. If somebody asks you what is the SI unit of dipole moment is given as, yes, magnitude of one of the charge multiplied by displacement vector, right? So magnitude, so this is coulomb, and displacement has unit of meter, right? Coulomb meter is the SI unit of your electric dipole moment, right? I hope that is understandable. Now the important question comes, the physical significance of electric dipole. So basically the important question is that why are we studying electric dipole moment, right? Or electric dipole, right? One of the good answer to that question is related to molecules, right? So whenever we talk about molecules, right, let me draw a molecule. Let's say I have molecule, let's say I have this positive nucleus, right? And let's say the electrons are these dots, right? They are these dots which are there, right? So basically whenever we talk about molecule, this molecule have two positive part and lot of negative part, right? Negative part is actually discrete, it is being divided in the space, right? Or the space of that atoms, right? So whenever the atom makes a molecule, right, so whenever this happens, there is always the center for positive part and the center for negative part. Now what I mean by center for positive and center for negative part, so we have studied in our 11th standard center of mass, right? Yes or no? Center of mass, and we know how to find out, right? Very similar, center of velocity, center of motion, all these terms we have studied, right? Very similarly, there is something known as center of positivity, a center of negativity, right? That means, now what does that mean? It means that if I have a positive charge here, if I have a positive charge here, then if I take an average of these two charges, then I can say the net positive charge is somewhere in between. Yes or no? Right? We call it center of positivity, right? So net is somewhere in the center, right? Very similarly, when I talk about the negative part, right, all the negative part, then in most of the molecules, when I calculate the center of the negative part, right, so they also coincide with the positive part. So the center of positive part and the center of negative part both coincide at the same place in most of the molecules. Okay, so when the center of positivity and the center of negativity, right, both coincide with the same same place, they both coincide at the same place, what does that mean? It means it is just like a dipole. You guys can assume, or you guys can visualize it like a dipole. You have two opposite charges separated by some distance. The only difference here is that instead of having any distance, they are situated at the same place. That means distance is 0, right? if the distance is 0, that means I can simply say dipole moment is actually 0. Yes or no, right? And we call these kind of molecules as non-polar molecule. These kind of molecules we call non-polar molecules, right? Okay, now does that mean all the non-polar molecules have zero dipole moment, or can you make it, can you give these molecules some dipole moment? Yes, you can give, if you provide it with some electric field. Now this is something which we will study in the next chapter, but just a hint of what we are going to study in the next chapter, just a glimpse, right, so that you guys can understand. So if you give a electric field to these molecules, then there can be a dipole moment, because what happens, the moment you pass electric field, these positive and the negative centers, they separate each other out. The moment they separate each other out, there's a distance between the positive and the negative part, and hence the dipole moment, right? I hope that is understandable, right? So examples of these kind of molecules are your CO2 is a good example of your non-polar molecule. Then CH4 is again an example of your non-polar molecule, right? And the other type of molecule is your polar molecules. Now polar molecules are those molecules which already have some distance or some space between the positive centers and the negative centers, right? They are known as your polar molecules. They already have some dipole moment, right? Why? Because they already have some distance between their center of positivity and center of negativity, right? So as they are having some distance, right, so the magnitude of one of the charges multiplied by the distance between them will give us the dipole moment, right? So example of your polar molecule is your water, H2O. H2O is a really good example of polar molecule, right? So the physical significance of dipole or dipole moment is that we can find out whether a molecule is a polar molecule or whether a molecule is a non-polar molecules, right? I hope that is understandable. I hope you understood, right? Okay, so if you have any doubt, if you have any query, you can ask it in the comment section, and I hope all of you are doing good. Stay home, stay safe.